Hello, welcome back to JP Academy ETAP MasterClass, where we produce specialists or professionals in power system design, analysis, and protection. We are still in the series on how to regulate the voltage level of an AC supply system, and in this session, I will be teaching on the use of tap changing transformers. That is, what they are, where they are used, when they are used, and most importantly, how they are used. So, let's begin. As already mentioned in our previous session, excitation control method for voltage regulation is used at the generation domain and therefore satisfactory only for relatively short lines. For long transmission lines, other methods of voltage control will have to be used. The use of tap changing transformers is one of the important methods of voltage control, and it is usually used where the main transformer is necessary. Yes, I am teaching on tap changing transformers, but for the purpose of clarity, I would like to explain what a tap changer is. So, a tap changer is a mechanism which is embedded in transformers, which allows for variable turn ratios to be selected in distinct steps. And this is done by connecting to a number of access points known as taps. These access points are known as taps, and they are along either the primary or secondary winding. The principle of regulating the secondary voltage is based on changing the number of turns on the primary or secondary. That simply means changing the transformation ratio. A decrease in primary turns causes increase in EMF per turn and therefore an increase in the secondary output voltage. Alternatively, the secondary output voltage can be increased by increasing the secondary turns and keeping the primary turns fixed. In other words, a decrease in primary turns has the same effect as that of an increase in secondary turns. Now, it is important to note that in the transformer, there is always a tapping on the high voltage winding, which when connected to the rated voltage gives the rated voltage on the low voltage side. This tapping is called the principal tapping. Now, the principal tap position is the point in which the supply voltage will be equivalent to the delivered voltage. That is, the voltage on the high voltage winding is equivalent to the voltage on the low voltage winding. Now, apart from the principal tapping, we also have the positive tapping and the negative tapping. What I mean is the number of turns included at other taps may be either larger or lesser than the number of turns used at principal tapping. The tapping at which the turns included are more than that of the principal tapping is called the positive tapping, while a tapping at which the number of turns included is less than the number of turns included at the principal tapping is called the negative tapping. So simply put, the tapping at which the turns included are more than the principal tapping is positive tapping, while when the tapping included at which the turns is less than that of the principal tapping is negative tapping.